Welcome to this video on linear relationships. In this unit, students learn to understand and use the terms rate of change, linear relationship, and vertical intercept. They deepen their understanding of slope, and they learn to recognize connections among rate of change, slope, and constant of proportionality, and between linear and proportional relationships. Here are the essential vocabulary words that will be introduced throughout the unit: linear relationship, rate of change, slope, solution to an equation with two variables. Students will consider what it means to make a useful graph that represents a situation and use graphs, equations, tables, and descriptions to compare two different situations. There are many successful ways to set up and add scale to a pair of axes in preparation for making a graph of a situation. Sometimes we choose specific ranges for the axis in order to see specific information. For example, if two large cylindrical water tanks are being filled at a constant rate, we could show the amount of water in them using a graph like this. While this graph is accurate, it only shows up to 10 liters, which isn't much water. Let's say we wanted to know how long it would take each tank to have 110 liters. With 110 as a guide, we could set up our axis like this. Notice how the vertical scale goes beyond the value we are interested in. Also notice how each axis has values that increase by 10, which along with the numbers like 1, 2, 5, 25 is a friendly number to count by. Andre starts babysitting and charges $10 for traveling to and from the job, and $15 per hour. For every additional hour he works, he charges another $15. If we graph Andre's earnings based on how long he works, we have a line that starts at 10 on the vertical axis and then increases by 15 each hour. A linear relationship is a relationship between two quantities where one quantity has a constant rate of change with respect to another. We can figure out the rate of change by using the graph because the rate of change is constant. We can take any 2 points on the graph and divide the amount of the vertical change by the amount of the horizontal change. Students will investigate linear relationships with slopes that are not positive. Here's an example of a line with negative slope that represents the amount of money on a public transit fare card based on the number of rides you take. The slope of the line graphed here is negative 2.5, since slope equals vertical change divided by horizontal change. Negative 40 divided by 16 equals negative 2.5. This corresponds to the cost of one ride. The vertical intercept here is 40, which means the card started out with $40 on it. One possible equation for this line is y equals negative 2.5x plus 40. It is important for students to understand that every pair of numbers, x and y, that is a solution to the equation representing the situation, is also a point on the graph representing the situation. We can also say that every point x and y on the graph of the situation is a solution to the equation representing the situation. Graphs with negative slopes often describe situations where some quantity is decreasing over time, like the depth of snow on warm days or the amount of money on a fare card being used to take rides on buses. Think of all of the rectangles whose perimeters are 8. If x represents the width and y represents the length, then 2x plus 2y equals 8, expresses the relationship between the width and the length of all such rectangles. For example, the width and length could be 1 and 3, since 2 times 1 plus 2 times 3 equals 8. We could find many other possible pairs of width and length, xy, that make the equation true. That is, pairs xy that, when submitted into the equation, make the left side and the right side equal. A solution to an equation with two variables is any pair of values x and y that make the equation true. We can think of the pairs of the numbers that are solutions of an equation as points on the coordinate plane. Here's a line created by all points x, y that are solutions to 2x plus 2y equals 8. Every point on the line represents a rectangle whose perimeter is 8 units. All points not on the line are not solutions to 2x plus 2y equals 8.